Hey guys, my name's Sam. I'm going to do another Leetcode easy question today. I'm going to be acting as a tech interview candidate, so we'll be using a Google Doc instead of an IDE because sometimes that's what you get in an interview. Let's pick one at random and I'll start the timer. Let's see. What do we got here? Number 1773, count items matching a rule. So you're given an array of items. Let's space this out so we can read it all. And you're given an array of items where each item has a type, a color, and a name. You are also given a rule represented by two strings, rule key and rule value. The item is said to match the rule if one of the following is true. If the key is equal to the type and the value is equal to the type, if the color is equal to the value, or the name is equal to the name, and return the number of items that match the given rule. So we only get one rule input. So the inputs here is like they give us a bunch of items and one kind of rule key and value. And there's only these three rules. And it will return the number of items that match the rules. So here, for example, it sounds like we're going to be iterating through the list and just doing checks for each of these rules at the moment. I'm not sure there's anything more complicated than that just yet. So in this example, there's only one item that matches the given rule. So we have been given the rule of a color and silver. So when the rule is a type, we have to match the type. When the rule is a color, match the color. And the rule is a name, match the name. If the rule is not one of those, then we don't care about it, I assume. So here we're matching by color. And the only one that matches silver is the computer. So output is 1. We don't even care about which one it is. We just care whether it matches. So we're filtering, it sounds like we're trying to filter a array by column, essentially, given a certain rule. And the rule is given by matching column value. It's kind of what it sounds like. Some questions I'd have for the interviewer is, how big is this array going to be? Could we get invalid arrays? Like, could they have more information than just these three? How do we want to handle that? Generally with Leetcode, we're just going to be given valid inputs and outputs, but that changes when you're getting an actual mock interview. So it's good to ask. And usually it's going to be it's not about something you solve yourself. It's about you asking the interviewer how you want them to how they want you to handle it. And then another example here is we got the same inputs, and this time we do it by the type, and it's a phone. And there's two phones in here. Okay. I think we can just iterate over this. If this didn't fit in memory, we'd have to create some sort of streaming input class, but that is not the purpose for this question. But it's good. We can go over to that in extensions later. Invalid values are not going to be there. Everything's going to fit in memory just fine. And how do we want to do comparisons is a question. For example, these are strings. Are we going to assume that they're... I guess we'll just do a straightforward string comparison. One could supposedly tokenize everything, but the process of doing that does not make sense here. So let's not complicate things any more than they need to be. Let's think about approaches. So approach 1, iterate through the list for each item. So we're given rule, key, and value. And then for each item, we can actually decide which index we're caring about based off of the rule key here. Search index is equal to, so like if key, so given a search index is equal to rule key, let's just say we create a dictionary right here. And we say that if it's type, search index is first one. If it's color, search index is the second one. And if it's name, search index is the third one. And then columns is equal to that. And we'll just choose by the rule key which search index we're going to use. That way, for each item, we're going to say if the item search index, like which one of those, is equal to the rule value, then we are going to return increment the count. Something along this line. And I'm not writing this in full code just yet because I already can see some ways we can optimize this, but I want to at least start thinking about, so iterating through lists is O of n for n items. Choosing which value this is constant time because there's only 3 rules, and that's always true. And then for each item, oops, sorry, we don't need to, it's not a 3-layer depth, this is just a iterate through the list. For each item, if the item index is equal to rule value, count is equal to 1. So we're just doing an O of n search through this whole thing. And so the end result is we're going to have a O of n time and O of 1 space complexity. And we can't do better than this in terms of big O because we have to check every single item. And we have to, and we can't use less than O of 1 constant space. We could optimize it within this big O, but this, I think in our case, is close enough to optimal that we're good to go. Run this, double check with the interviewer how they feel about this, and they're like, all right, let's go ahead with it. So we will start implementing. So what I'd like to do is start with a skeleton. Oop. And we'll call this count for now, items. And our input's going to be items, which is a list of lists of objects. Lists of objects. I think we can do it this way. I'm not sure. I guess they'll be strings. And our output is an int for the count. What happens if we get no items at all? Then the count should be 0. That makes sense. This will be kind of a static thing created once. We could even put it outside the loop. And now here's where we can be a little bit more optimal. So what we can do is do the sum of item search index equals the rule value for item in items. And we can just return the count of that. And that is equivalent to this rule right here. So I've already wrote it out here for the interviewer to understand. And now we can short form it into an iterator process, which will be a little bit more efficient. Well, it'll actually be equivalent. The nice thing about using sum with Boolean values is that a Boolean true is counted as 1 when you sum it all together. So we're basically, for every item, we're summing the values together. We're doing this as an iterator rather than a list, so we don't have to store any extra space. So we have O1 space still, and yeah, technically you could put this under here, but just for clarity, we're keeping it outside. We no longer need count. And the sum for an empty list will be empty, so sum 0. If list was none, if items was none, we'd be in trouble. But for the purpose of this question, we're guaranteed that items will exist and is valid. They're all strings. We're doing string comparison here, so technically it's O for the number of characters, but that's considered constant, it looks like, for this case. We could argue this is O of n times c in that case. This is where if it mattered, we would try to tokenize everything so it becomes constant. Okay, let's have a look. All right, hopefully you guys can see that. So they call it count matches, list of string, and and the rule key. That is a mistake I made, as I forgot to pass in the rule key here as a string. So don't forget that. And the value too. Don't forget that either. Even though I use those things. So this is something where you should keep in mind, and also the interviewer will probably call out and ask. But otherwise it returns the int just fine. Let's make sure that it is indented correctly. So 2 indents. We have our fixed columns type. This is a constant size dictionary. And searching through its O of 1. We're summing, and for item and items. There are some other tricks, like if we had been passing this set of items in as a NumPy array, we could do checks along the way. For example, with NumPy arrays, you could do like items. Let's say we have our search index. That'll be all the columns equals the rule value. And then you could do something along these lines. And then it would be sort of a one-liner, but it's virtually identical to this one actually. So we don't even need to do that. All right, let's have a look and see how this should go. I'd like to make sure before I run this, let's do a check. Run through an example. So we're about 11 minutes in. So let's say we've been given our input items is these 3 things. And our rule is color and silver. And rule value is silver. So questions to be asked is what happens if we're given a rule key that doesn't exist inside of our keys? If the interviewer wants so in the Leetcode you usually don't have to worry about that, but usually in an actual interview you would want to ask the interviewer, do we need to worry about invalid rule keys or rule values? And ask them, and usually they'll say either no, or if it's invalid, they should return none or something along those lines, or raise an exception. Whatever it is, you've talked it out with them and it's not an issue. And you just implement as is. Okay, so here it's chosen color, so we passed in a rule key of color. So the columns, the rule key is color 1, so search index is 1, which as we've established earlier is the second index, which is correct. So search index has become 1. Then we check whether the rule value, which is silver, is equal to the item of search index. So for the first one, no, so it's false. Second one is true, so it's true. Third one is false, so it's false. So sum of that should be equal to 1, which is the expected answer. All right, I think I'm ready to go and have a go at the run. So let's see what we get. See if we have any edge cases we're missing. All right, test cases seem to have passed. Expected output for that. Before I run it for the submission, let's just one last time think about any edge cases. What happens if we got an empty array? Would it break because it's trying to search through the items? No, it would sum over an empty array 0. If it was a single length array, the same thing would sum 1 if correct. All right, let's submit. And it was accepted. Always good to see. In a perfect case, you are able to write a solution that runs the first time like this. I'm always happy when it happens. Not strictly necessary in an interview, but definitely nice to have. Don't worry too much about the speeds and times. Again, for these kind of questions, when they're this small or simple, it's more with how the backend ran it than it has to do with the algorithm itself, unless it's extremely inefficient. So yeah, I'm feeling pretty good about that. Let's quickly talk about the extension I was referring to earlier. So let's say we finished a problem. We're about 14 minutes in now, and the interviewer says, great, what if we have a system that is, what if we want to keep a running count for a live system that has items coming in constantly? So it's a good question. Like, so we can't. So one thing you could do, the brute force approach, is keep a list of all items. Every time a new item comes in, just run a function over all the items again. So you could imagine that every new item is another O of n, an O of n call. Is another O of n call. This will rapidly get really slow as our n's get really big. So as items, so let's say, yeah, this just gets very slow, pretty expensive over time. Let's just call that. Can we do better than that? Yeah, we should be able to. Ideally, we want O of 1 for every new item that comes in. Because really all we have to do is keep the current count, and then just do this check for every new item that comes in. And there's a couple ways we could do that. We can start. One of the ways we could do that is, let's just say we have a class that's a running count of some sort, and we have our init that's going to take in our, oh, interesting, that takes in our rule key and rule value. And I'm just putting this all out. We could also say self.index is equal to what we did earlier over here. So now we have this locked in, and now for every new item, add item, we pass in this item that's the list of string, and it'll return the current count so far. So we'll need to keep track of self.count. We might even have a reset function, you know, def reset self and self.count equals 0. So, you know, something along those lines. And so every time we add a new item, we're going to just do this little call right here. Self.count plus the item is equal to the self.search index and the rule value, and return self.count. Then we could also add, you know, multiple items if we wanted, and this will start to emulate our original. Let's just do it the straightforward way and then return self.count. So it could be something along those lines. And the point here is that this isn't particularly difficult. This is just kind of a simple extension that this concept of like streaming is something you should keep in mind, because not only is it really useful in real life coding and systems, but being able to kind of vary a simple question such as this one in a slightly different way, an extension, and being able to understand how it works and how it could be modified. This is what kind of shows you as a good interview candidate or not, and hopefully a good programmer as a result. Well, hope you guys enjoyed this and have a good day. See you next time.